Hi everyone, we are Group B2E, consisting of 6 members. Today we are excited to share our statistical analysis with you on passenger satisfaction with LRT services. Light rail transit is gaining popularity due to its affordability, efficient, and environment benefits. As the number of passengers increases, improving service quality has become more important. This study analyzes survey data to identify the main factors influencing passenger satisfaction. The results will help management make informed decisions to enhance LRT services and improve the overall passenger experience. Here are our 6 group members. Next, we'll present our problem-solving process and key insights to everyone. Hi, I'm Tang Ray, in charge of Part A and B of Question 1. For the Part A, to create a normal probability plot in Excel, first copy the age column to a new sheet and sort it into ascending order. Then using the formula, calculate the percentile for each value. Next, compute the z-values. Insert a scatter plot with z-value as the horizontal axis and sorted age as the vertical axis. Finally, add a linear trend line and check to display the r-value. From the graph, we can know that the plotted points roughly follow the trend line, indicating that the age data is approximately normal distributed. For Part B, I conducted the verification using Excel and handwriting calculation. The steps of Excel are as follows. 1. Group the age column by gender. 2. Calculate the sample size for each group. 3. Compute the mean age for each group. 4. Find the standard deviation for each group. 5. Calculate the standard error. 6. Calculate the t-value. 7. Find the p-value using the t-distribution. Finally, we find that here is no statistically significant difference in mean age between male and female respondents at the 5% significance level.
Hello everyone, my name is Mingxi and I solved the question 1 C and D. Let's begin with question 1 C. What is the probability that the simple mean age is greater than 36? We are given a simple mean of 37.04, a simple standard deviation of 7.39, a simple size of 110. First, we calculate the standard error by dividing the simple standard deviation by the square root of the simple size. Then we compute the z-scores by taking the difference between 36 and the simple mean, 37.04, and dividing it by the standard error. Using the z-score table, we find that the probability corresponding to this value is approximately 0.929, meaning there is a 92.9% chance that the simple mean is greater than 36. So the probability that the simple mean age exceeds 36 is approximately 92.9%. This means it's very likely that the mean age is greater than 36. We can also visualize this in the graph on the right. The red shaded range represents the area under the curve where x greater than 36. It clearly covers both of the right tail, emphasizing how high this probability is. Now let's move on to question 1D. What is the probability that the simple mean fall between 33 and 35? We use the same standard error 0.705 and calculate the z-scores. To find the z-scores for 33, we subtract the simple means 37.04 from 33 and divide by 0.705. This gives a z-score of approximately negative 5.735. Similarly, for 25, we subtract 37.04 from 25, then divide by 0.705, resulting in a z-score of around negative 2.896. Then we find the probability between these two z-scores using the cumulative distribution function. So we subtract the probability at z equal negative 5.035 from the probability at 0 equal negative 2.896, which give about 0.00193 or 0.19%. So the probability is only about 0.193% or 0.19%, which is extremely unlikely. As you can see from the graph, the orange shadow region is extremely narrow and far from the center, reinforcing how unlikely this outcome is.
Hello everyone, today I will present the part of our group analysis from question 2 of the case study. Our focus is on passenger satisfaction with the LRT service. We use the survey data to answer 2 questions. First, we compare satisfaction levels for 2 facility items. Second, we test if female passengers are more satisfied than male passengers. Let's start with the first part. FQ1 is about seating capacity. FQ2 is about disabled-friendly features. We say a passenger is satisfied if it gives a score of 4 or 5. From our data, for FQ1, 55 out of 110 passengers were satisfied. For FQ2, 68 out of 110 passengers were satisfied. That means the satisfaction rate is FQ1 is 50%. FQ2 is 61.8%. We calculate the difference in proportions, which is negative 0.119. Then we constructed a 90% confidence interval. Let's move to the second part. We tested if female passengers are more satisfied than male passengers. We use the score from IPS1, which stands for passenger satisfaction. The average score for female passengers is 3.71. The average score for male passengers is 3.70. We use a t-test to compare the two means. The p-value from the test is 0.4559. Since the p-value is greater than 0.05, there is no significant difference between the two groups. While we use the standard formula for two proportions, the confidence interval is from negative 0.228 to negative 0.009. Because the interval does not include 0, it shows the meaningful difference between the two items. Passengers are more satisfied with FQ2 than FQ1 in this survey. Okay, to summarize, we found a difference in satisfaction between two facility items. The confidence interval shows that passengers are more satisfied with the disabled-friendly feature. However, there's no strong evidence that female passengers are more satisfied than male passengers. Thank you for listening.
Hi, I'm Chinga Jin. In this part, I'll be presenting the solution to question 3, which involves the question 3A and also the 3B, hypothesis testing with rated samples, and also the analysis for variance ANOVA. So let's get started with the question 3A, hypothesis testing. The selected variables here are service quality against the timeliness. And first, we define our hypothesis. The null hypothesis, H0, is actually no significant difference in satisfactions between the two lines. And for the alternative hypothesis, the H1, there is a significant difference in satisfaction level. And now we move on to step 2, 0.05 as the significant level. And step 3, since the data for both lines are paired, meaning that the same passengers give satisfaction rating for both lines, so that we apply the pair sample t-test here. And for the step 4, state the decision rule. We will be rejecting the H0 if the t-value is greater than 1.982 or lesser than negative 1.982. And now for this part, we will be calculating the t-value of these samples by using the formula given. And the t-value calculated is 6.33, which is greater than the t-critical value, which is 1.982. To the final step, in our case, since the t-value is greater than 1.982, we rejected the null hypothesis. This means there is a statistically significant difference in satisfaction level between the two LRT lines. Passengers are more satisfied with the service quality than with timeliness. And next, in question 3B, we use one-way ANOVA to test whether there are significant differences in passenger satisfaction based on education levels. Firstly, we state our hypothesis. The null hypothesis H0, all education groups have equal mean satisfaction, while the alternative hypothesis H1, at least one group have a different mean. And for the step 2, 0.05 as a significant level. Step 3, we'll be rejecting the H0 if F value is greater than 3.89 or the P value is lesser than 0.05. And for the step 4, we will be using the Excel formula to calculate all the values such as the average, the variance, and sum and count. And now for the step 5, we will be calculating the F76 and also the P value. So before we calculate that, we have to get the value for the variation among groups, within groups, and the total of it. And we will get the final result as the F value equal to 0.021, and hence the p-value equal to 0.979. Lastly, we interpret the result. The F-statistic is lesser than 3.89, and the p-value is greater than 0.05. We fail to reject the null hypothesis. This means that there is no significant difference in satisfaction level across different education backgrounds. Thank you.
Hi, my name is Celine. I was assigned to question 4A. Now I will explain the chi-square test of independence that we use to analyze the relationship between gender and private transport ownership. So we begin by defining our hypothesis. The new hypothesis, or H0, states that there is no association between gender and the use of private transportation. On the other hand, the alternative hypothesis, which is H1, states that there is an association between gender and the use of private transportation. Next is the second step, which is state the alpha. So I take the alpha as 0.05. The third step is to calculate the degree of freedom, which I get it as a 1. So at the right side, there is a chi-square critical value, which I get is 3.841 from the chi-square distribution, with a 1 degree of freedom. Is the fourth step, which is take the decision rule. If chi-square statistic is greater than 3.841, then we will reject the null hypothesis. After we get the observed frequencies, we should use it to find out the expected frequencies. So the right side shows the steps that how I get the expected frequency for each. So first, we should find out the people that own their private transport, which is for male will be 15 and female is 45. So total out will be 16 and divide by 110, we'll get a 0.54. So expected frequency for people that own their private transport for male will be 0.54 times with 33 and round up will be 18. For female is 0.54 times with 77 overall and we'll get a 42. So for those that don't have their private transport, for male will be total 33 and minus with those have their own private transport, which is 18, we'll get a 50. And for female is 77 minus by 42 and get a 2. Step 5 is to calculate the task statistic by using the formula provided here. And at the right side, I summary all in a table. Yeah, so at the below is the solution, which is for male that own their private transport will be 0.5, and that those don't have their private transport will be 0.6. And for the female with their own private transport is 0.2143. If those don't have their private transport will be 0.2571. So sum up overall will be 1.5714. So last but not least, we should state out the result. So from the graph at the below, at the right side below, it showed that the chi-square statistic value, which is 1.5714, is less than the chi-square critical value, which is 3.841. So to summary, we do not reject the null hypothesis. Last but not least, we should state out the result. So from the graph at the below, at the right side below, it showed that.
My name is Daniel and I was assigned to answer question 4B and question 4C. So for question 4B, in this section, we use the Man-Whitney-U test to examine whether satisfaction scores for emergency information SS4 differ significantly between male and female passengers. The test is appropriate here because SS4 is an ordinal variable and we are comparing two independent groups, males and females. First, we need to state the hypothesis. Then I summarize all the information in the summary table. Then we can start to compute Man-Whitney-U statistic for each population using the formula given. So we will get that the Man-Whitney-U statistic for male, which is U1 equals to 1,476, while for female U2 equals to 1,065. So I choose the smaller u, which is u2 equals to 1065, to compute the mean and standard deviation of u statistic. Then we start to compute z statistic. We use the smaller u to minus the mean and then divided by the standard deviation, and we will get the result which z statistic equals to negative 1.3404. Next, we make decision and conclusion using critical value. For significant level 5% and the decision rule is one side up until alternative hypothesis as I stated before, we found that the critical z value equals to negative 1.6449 from the z table. Then we found that the critical z value is smaller than the z statistic. So z statistic does not fall in the rejection region, so we do not reject the null hypothesis. So we can conclude that there is not sufficient evidence of difference in the distribution of satisfaction scores SS4 for male and female passengers. We can also make decision and conclusion using p-value. We found that the p-value equals to 0.0901. So since p-value is greater than 0.05, thus we do not reject the null hypothesis. We conclude that there is not sufficient evidence of difference in the distribution of satisfaction scores SS4 for male and female passengers. So for question 4C, we conduct a Kruskal-Wallis test to determine whether there is a statistically significant difference in perception of FQ3, which is the proper condition and maintenance of elevators or escalators across different employment status groups. We selected employment status as the independent variable because different groups may have different experiences with LRT facilities. So first, we also need to state the hypothesis. I also arranged the data in Microsoft Excel, and I summarized all the information in the summary table and compute Kruskal-Wallis H test statistic with 3 degrees of freedom. Next, we compare the H value, which is equals to 7.8476, to the critical value from the chi-square distribution for 3 degrees of freedom and significant level 5%. From the chi-square distribution table, we know that the critical value equals to 7.815. Since the computed value of H is greater than the critical value, the null hypothesis is rejected. There is sufficient evidence to conclude that there is a difference among the employment status groups with respect to the variable being measured. In conclusion, this study found that passenger satisfaction with LRT service is generally consistent across gender, age, and education level. However, satisfaction with emergency information (FQ4) was higher than with elevator and escalator maintenance, which is FQ3, and FQ3 ratings differ across employment groups. So these results highlight specific areas for improvement to enhance the overall passenger's experience. So that's for us. Thank you.